Hey guys, today I'm going to present my new project, which is Person AI, which is a platform where you can create your own personalized character chatbots, and you can chat with it. You can get the responses in audio formats also. So let's look at the demo. I'll copy this link from my Colab notebook and paste it here. First, I'll show you the demo, then I will get into the code of it. Set the URL. Let's upload an image. I have already created an image of an elf. Let's give it a story that you are a grand elf. Let's see. Okay, so set reference audio. I'm not going to set the reference audio right now. I will first chat with it and see how the textual chat is going on, and then I'll set the reference audio. But you can do this if you want. Okay. Hey. Okay, so as you can see, it is providing the response according to the backstory I have provided. uh, who are you? Yeah, so it is working pretty cool. So let's switch to voice mode. I'll upload the reference audio, for which I've downloaded this Amitabh Bachchan's oh, voice audio. I'll upload it. Now the reference audio has been set, and I can chat with it, and the character AI will provide the response in an audio format. Maybe tell me a joke. Now this audio takes a bit of time because it first gets converted to normal textual response. Then I have a model, a text to speech model, which converts the audio to the text to audio. So it will take some time. Let's wait for that. It took some time, but I finally got some response. Let's see.
A moment of levity amidst the weight of existence. Very well, here's a jest, though I confess. Humor is a fleeting thing, much like the ephemeral beauty of a spring blossom. Why did the train cross the road? To get to the other leaf.
Let's look at another example, maybe. What magic can you do? Okay, let's wait for the response. Okay, so the response was pretty long, and it took some time. It took about 5 minutes. Let's look at the response now. You can obviously opt for shorter responses and get faster responses then.
As a grand elf, my mastery of magic is vast and varied, spanning across numerous disciplines. To give you a glimpse, I can witch dim low winds, command fire, water, earth, and air with ease. Summon storms, conjure walls of flame, shape the very ground beneath your feet, and control the winds to my will, a shape reality. Bend the fabric of reality, though such acts are not to be taken lightly. I can manipulate time.
Okay, so the response looked really well, and of course, this was a really long response. It is about 30 seconds, and you can, of course, go for shorter responses. Okay, and the response time will also be shorter then. So now let's move on to the code, and let's see how I implemented it. Now let's look at the system design of this project. The system has been divided into three parts: the React frontend, the AI workflow, which includes the Fast API backend, and using Colab as a GPU server. Now let's move from right to left. So in Colab, we have two models. One is a large language model. We have used Gemini in this case. You can also use other small models like Gemma or 5.3.5, which can fit in Colab. And we have used Zonos as a text to speech model. So the user can provide the prompts, and we can get response from the LLMs. And in case of the text to speech, we need to first provide a reference audio from which the speaker embeddings can be extracted. and then we have to provide the text which gets converted as an audio and yeah, return back. Okay, so now we have also created a fast API server in Colab, and as Colab is a quite sandboxed environment, we have used PyNG Rock to expose the APIs. Now let's move to this. Okay, so in the React front end, when we set the backend URL, this URL is of the Colab server. Okay, and we then set the backstory. So for that current session, the backstory gets set. Then when we send the query, the prompt builder takes the user query, the character design or the backstory that we have already set, along with the chat history that it holds, and it generates a prompt. Now that this prompts goes to Colab, and we get the response in textual format, and we return it to the front end. Okay, so in text, in terms of the audio, what we do is we set a reference audio at first. So this TTS handler takes this reference audio and sends it to this Colab notebook where we have this Zonos model. So once the reference audio has been set, the speaker embeddings are extracted, and then what we do is we provide queries again, normal textual queries. Then again the same path follows, the user query along with the character design and the chat history. We create a prompt. Now this prompt goes to the LLM, we get a response, and then this response gets returned to TTS handler, and then TTS handler again sends another API request to Colab notebook, and in this case Zonos TTS model converts this textual response into audio response. Now this audio response gets returned to our AI workflow, and then further to our front end, and we can of course see the audio response as I've already showed. Now let's look at the Colab notebook. So at first you have to define your Google API key to use Gemini. You have to define your key here, and then we'll make some necessary library installations. This is LangChain Google Gen AI, and here I'm defining the LLM. I'm using Gemini 2.0 Flashlight. Now making some installation for our text to speech model, and after that making some further installation of libraries which are necessary for the text to speech model. Now here we are defining the model, as you can see, Sonos from pre-trained. Okay, now we have two methods here. One is add reference audio, which takes our audio and it extracts the speaker embeddings and returns that. So we have this function here, and another is generate speech, which uses the speech embedding and our text, and it generates an audio. Okay, and it returns the file name of the audio. Okay, now for creating the server we need fast API, UVcorn, and for reverse proxy we need PyNG Rock. We also need Nest Async IO to run async functions in Colab notebooks. So you have to define your NGRock authentication tokens here, which you can get from their website. So making some necessary imports here, defining the function. Now these are the three APIs that I have created. One is for chat completions, which takes textual input. As you can see, query request, it takes query and it returns the LLM response. Then this is the upload reference audio API, which takes file input. We provide the file, the reference audio file. In this case I provide an audio of Amitabh Bachchan's speech, right? And we get the speaker embeddings here. Okay, here we initialize the speaker embeddings, and this speaker embeddings will be used throughout this session. Okay, so then after that this upload this v1 tts upload text, it accepts text as input, and it generates, as you can see, I'm using global speaker, so it generates an audio file. This is the folder path, file path of this audio file, and it returns the audio file. Okay, so now these are some code for png rock that we need, and after that our server is running. Okay, so this is the directory that contains the front end, the back end, and the AI workflow. The front end is quite easy, so I want to go over it, and let's go to the back end. So in backend, in main.py, we have defined the APIs and the server. Okay, we'll go to each of these API one by one, but before that, let's look at the other files. In chatbot.py, we have created a class called custom experience, which has LLM, backstory, and memory limit as class variables. Then we have this method called create agent, which creates a prompt from the given backstory and the provided history and input of the user. Now I have created an instance of this conversation buffer window memory class of LangChain, which is quite handy, and provided a memory limit as provided in here while defining an instance of this class. So yeah, now I have wrapped all this into a conversation chain. I provided the LLM, the prompt, the memory, and set verbose equals to true, so we'll be able to see all the responses in log. Now in custom LLM, I have defined this custom LLM inherits from LLM class of LangChain, and this has a class variable called URL. Now so this function calls the collab server, and it sends the user's query to the collab server and fetches the response and just returns it. So it is quite simple. Now for this TTS handler class, we are also defined a class variable URL here. Then we have this two methods. One is set reference audio, which sets a reference audio given the audio file path. So we provide the audio file path, and it sends this audio file path. It sends this audio file to this API, which is of the collab notebook, of course, and it fetches the response that it has been set or not. Okay, then this is a method called generate audio, where we provide the text. Now this text gets sent to the collab notebook again, and then the Zonos TTS, it converts the text to speech and returns the audio file. So it returns the audio file and it saves it, then provides us the file path. Okay, now let's move on to the main.py. Okay, so here we have defined the server, some classes. Okay, this is for cleanup, this is not necessary, and yeah, this method is for setting the URL. Okay, note that I'll be using global variables from now on, because I want the variable to be consistent throughout the code. Okay, so given the URL, I'll set the collab URL here, and of course yeah, I'll be defining an LLM, an instance of this custom LLM, by providing the URL. So we have the URL also, the collab URL, and the LLM. Okay, and if the backstory is present, then we'll be creating instance of this custom experience, okay, by providing the LLM and backstory, and a conversation memory of 3, and we'll be creating an agent for that. Okay, and for this next API set backstory, we'll be providing the backstory, and if the backstory is not present, and we'll be extracting the backstory, we'll be setting it. Okay, and after the backstory has been set, we'll be creating an instance of this custom experience by providing the LLM and the backstory. All right, this is a simple API for just getting the backstory. Now in this query API, we provide the query in textual format, and the character and we run this function character chatbot.predict and provide the queries to it. Okay, and we get the response and return it. Now in this API, we provide this API called set reference audio. We provide audio file. Now we run this function tts dot set reference audio, and we send the file path of the audio. Okay, so we can get the speaker embeddings and all that, and after that we just return the message. Okay, and for the last API query to speech, we provide the query in textual format, and we run this character chatbot.predict function, and we get the response of the chatbot or the LLM, you can say. And after we got the response, we pass the response to tts.generateAudio, which gives us an audio file of the response, which we return to the front end. Okay, so that was it about my project. I hope you guys like it. Okay, let me know what I can improve about it, or what do you suggest. I'll of course provide the link of my project in GitHub. You can make all the modifications you want to it and all. Okay, thank you, bye.